we did B, and it's good to look at B because a reminder, how do we solve the basic steps for solving a log equation? The main goal when you have a log equation is to change things to the exponential form using the definition, right? This in the orange box here, which looks black. Don't let your eyes deceive you. Inside that orange box is definition of a logarithm. If you have the log form, you can always change it to the exponential form. Log solve for exponents. So if you have log 5 of 25, the 2 is the exponent, the 5 is the base in both of them. So you could change it to exponential form. So we did that in part B. We got a single logarithm, said log solve for exponents, so you knew that that 3 was the exponent, the base is 2, and this is the step that everybody forgets because it looks unmathematical. You've used a definition to change things and write it in a different way. Now the reason we left A is you could do A exactly the same as we did B, get a single logarithm and solve for it. However, there's a shortcut in A that I want to show you. So the shortcut in A, first of all, can you see that on the right-hand side, I could combine those to be a single logarithm by doing x plus 1 times x minus 1, x plus 6 times x minus 1, which would give me x squared plus 5x minus 6. I still don't have a single logarithm. If I wanted to get a single logarithm, I would have to move the log 6x over to the other side. Okay? Don't write this down, but just watch. Because this is the way I'm going to show you the shortcut next. But if you didn't use the shortcut, you would get 0 on this side and have log x squared plus 5x minus 6 and subtract log 6x on that time. And subtracting means I can write this as a single logarithm. And once I have a single logarithm, remember that this logs solve for exponents. And so the base is 10, the exponent is 0, and it would equal again, what is 10 to the 0? 1. And then to get rid of the fraction, you can multiply both sides by 6x. And here, you got a quadratic. I think we could solve it from here. Okay? I'm going to now show you the shortcut. And the shortcut only works if you have a log on one side equal to a log on the other side. And the bases are the same. This is very similar to the step that you do next is very similar to what we did when we started solving exponents and got the bases the same. We went, so by observation, log of 6x equals log of x squared plus 5x minus 6. If they're the same, does it make sense that the 6x inside the first one has to equal the inside of the other one? Does that make sense of shortcut? Now, it only works if you have log equals log. Just like with the earlier part in the powers, it only worked if you had a single power equals another single power and the bases were the same. But look at how much, right? We got to this step without doing 1, 2, 3, 4, 5 steps we saved. So that shortcut is very nice, and now we can make one side equal to 0. Factor will be minus 3 plus 2, x equals 3, x equals -2. And we have to plug it back into the original equation. 3 is okay because when you plug it into the original equation, you only get positive values, but negative 2 makes you take a log of a negative number. Next week, I am going to give you some more examples to practice this. I'm a little bit mad at the textbook because the textbook is misleading you just a little bit. Not misleading you, but it's tempting you to misunderstand something. The temptation that the textbook is doing. Did you notice that we canceled out the negative 2 here? And the last time we canceled out the negative 4. And the first time we canceled out the negative 5 or something. You might get tempted to think, oh, if I get a negative answer, I should cancel it out. That is not true. In fact, I could make an example with 2 negative answers that both work. I could make an example with 2 positive answers that both don't work. I could make an example where the positive one doesn't work and the negative one works. You always, always have to take those and go back to your original equation and plug them in. And what is not allowed is taking the log of a negative number. So could you see that if your original equation had something like this, that negative 5 would be fine? Because negative 5 plus 1 is positive 6. It's just taking the log of a negative number that's bad. Not getting a negative number as an answer that's bad. But the textbook would tempt you, oh, negative answer, stroke it out. No. Sometimes both answers don't work. Final exam, about 7 years ago. Very first question was a log solving question. Very first question on the exam. The answer that you got only gave you one answer, and when you plugged it in, it didn't work. It was like, I was like, oh man, as far as psychology of writing a test, that's not very nice to students. You spend all of your first page on the first question, you're like, gearing yourself up, getting energy ready for a 3-hour exam, and your very first question is like, it doesn't work. No solution. My confidence is fine. And that was the right answer. But everybody who's like, you just see shoulders go, oh no. Like they wouldn't do that to me on the first question of the exam. And it was. There was teachers like, hey, question 4 or question 8, like, okay, you can give me that question sort of in between the test. It was a fair question, because we have to check. But the first question of the whole test to be like, no solution. You want to get some confidence. They say, good exam, usually the first question is one that's like, it's doable, you get the right answer, you get a little bit of confidence. Like if you get a couple right, then when you get to the 4th one, you can't do that one, you're not like destroyed. But you don't want to like, all right, I'm going to start off this exam and just crush. Then I'll give you